that passes through the points -2, 9, 1, 6, 3, -4. Okay. So we're not told that any of these are a vertex or anything like that. If you were given a vertex, you could write it in vertex form, but I wasn't given a vertex. I was only given points. So what we had to do is we had to say each one of these represents an X and a Y. X and a Y, X and a Y, X and a Y. And then from that, we wrote out just the blank regular standard form of a quadratic. What does regular standard form of a quadratic start with? AX squared plus BX plus C equals Y. Okay, and what we did with these points is we took each one of these points and we plugged it in for the X and the Y. Plug in for X and Y to basically write ourselves 3 equations. Now the tricky thing about this, the only thing that usually tricks people is remember you're plugging the first number in for X, not for A or B or C. So if I take -2 and plug it in right here, what would be -2 squared? 4. And then times A would be 4A. Okay, on this one, B times -2. What would B times -2 be written as? B times -2, what? Minus 2B. And then this last one doesn't have an X to plug in, so just write C. And then what am I going to put where the Y is? 9. Okay, did the first one. Okay, and then we take the second one, and again we're plugging in for the X and then the Y. Okay, taking 1 and plugging it in. What's 1 squared? 1 times A would be just A, 1A. And then we'll have B times 1. Yep, just B. And this one doesn't have an X, so nothing to plug it into. Just bring down C. And then what do I put for my Y? 6. Okay, and then last one we're taking the 3 and plugging in for the X. 3 squared would be 9, so that's 9A, 9 times A. And then we'll have B times 3. B times 3 is 3B. And then bring down your plus C, and we'll write our -4. Do y'all remember how we solved this in the last unit? We did not use elimination. What did we use? We did not use substitution. When we did this exact question in the last unit, we used a matrix equation. Y'all remember? Yeah. Okay. So we took this and we wrote it as a matrix equation. And I'm just going to remind you there's 3 parts to a matrix equation. There's the first one, which has your coefficients. And then we have the variable matrix. And that's equal to the constant matrix. Coefficients, variables, constants. So I'm going to take the coefficients off of my variables here and write them in my coefficient matrix. For the top row, what are its coefficients? 4, -2, and C's coefficient is a 1. Second row's coefficients? 1, 1, 1, and 9, 3, 1. Those variables are A, B, C. Very good. And my constants are 9, 6, -4. Okay. Now remember when we type this in, we type in which 2? Yes, constants and the coefficients. This one and this one. The first one we type in for A, the second one we type in for B. This middle one is actually our variables, but that one is not the one that gets typed in the calculator. So we're going to press, let me get out of there, second, and then X to the -1, which pulls up your matrix menu. Where do we go next? Edit, arrow right to edit. I'll select matrix A. What size is matrix A? 3 by 3. Make sure you type them accurately. Don't miss any negatives.
Or the negative
We'll exit out of there. We'll do that process again. What size is B? 3 by 1. All right. Now remembering what we have to actually press to get the answers. The variable matrix, aka the answers, is found by doing what? Yep. Inverse of a to the power of -1 times b. So we have to tell the calculator to do that in order to get the answers. Select the first one, do inverse. Select the second one. Press enter. I can tell this is the exact same question because we had this before, and then I said, what if the answer was all in fractions? How would we change them to fractions? You would press math 1, enter, and it tells you them all in fractions. Now remember, this is just the a, the b, and the c of your standard form quadratics. So what we have to actually do is go back and write that a, b, and c. Go back and actually put them in your equation. Yeah, I'm going to do the fractions, because then I like to bring up a little something else that people always get confused about. -4/5 x squared minus 9/5 x plus my c, so plus 43/5. And then here's where I always say, should we multiply by 5 to get rid of those fractions? No, why not? Why do we not want to multiply by 5? Don't do that yet. Not yet. Why do we not want to multiply by 5? Because then you'll have multiply 5 by y, and you'll have 5y, and you don't want 5y. Because you're about to see that won't work on the next one. Yeah. Okay. Oftentimes on these I'll also ask, like, I'll give you something like this and kind of force you to do it this way. Yeah. You even saw that on the test. I didn't write it exactly like this because I knew y'all would do that. I only gave you 2 points, so you couldn't do it. Alright, extend the method you just used to find the equation of a third-degree polynomial that goes through the following points. Alright, third-degree polynomial, let's think about what its standard form would be. It's not ax squared, what would it start with? Ax cubed plus, what would be the next? Bx squared plus cx plus d equals y. Yep. How many missing variables does this one have? Like how many are we going to have to solve for in the calculator? On this one we solve for a, b, and c. How many does this one have? 4. It has an a, a b, a c, and a d. If you have 4 missing variables, how many equations do you need to write? 4. Yeah. 4 equations, 4 variables. We're going to do the same process. We're going to take each one and plug it in for the x and the y. One, -7, -2, -40, 462, and -1, -13. All right, and again, we're plugging in for the x and the y. We're not plugging in for the a, the b, the c, or the d. Starting with the first one, taking that 1 and plugging it in. 1 to the third power would be 1. 1 times a is still a. And then we'll have 1 squared times b. What am I writing for 1 squared times b? B. C times 1? C. And then plus d. D doesn't have an x, so just bring it down. And we'll write equals the y variable, -7. Okay, for the second one, we're plugging in -2 for the x. -2 to the third power. What's -8? Right, -8 times a is -8a. -2 squared, 4, so that's 4b plus 4b. C times -2, negative 2c. And then just write the d equals what y variable? Negative 40. Okay, plugging in 4 for the x, 62 for the y. What's 4 to the third power? 64. So 64a plus 4 squared times b, 16b. 4 times c is 4c. And then just a d equals what y? 62. And one last one, plugging in for negative 1. What's negative 1 to the third power? Negative 1. So that's negative 1 times a, which is just, you can write negative a, you can write negative 1a if it helps you remember that that should be a 1. Negative 1 squared? 1. 1 times b would just be plus 1b. And then we'll have negative 1 times c, which is negative 1c, plus d equals negative 13. All right, from there, let's put together our matrix equation. Top row of coefficients is 1, 1, 1, 1. Second row of coefficients would be negative 8, 4, negative 2, 1. Third row would be 64, 16, 4, 1. And then negative 1, positive 1, negative 1, positive 1. My variable matrix would have the letters A, B, C, D. And that's equal to the constant matrix. Negative 7, negative 40, 62, and negative 13. All right, getting that typed in. What size is the coefficient matrix on this one? 4 by 4, right. Editing matrix B. What size is matrix B? The constants? 4 by 1. Okay. Now remember what we actually have to type to get the answers. Yep. The inverse of matrix A times B. Inverse of A times B. Okay, all whole numbers on this one, so we don't have to worry about turning it back into fractions or anything. Last thing we need to do is literally just make sure we write that as an actual cubic function. Don't just list out A, B, C, D. Write it as your function. So my function would be, the A is 2, so 2x cubed. My B is negative 4, so that would be minus 4x squared. My C is 1, so that would be plus 1x, which you can just write x. Minus 6. I will give you a little hint. Whenever I put questions like this on a test, I will make the answers always nice, pretty numbers like this. So if you ever get crazy numbers, guess what that means? You did it wrong. You typed something wrong. Go back, check your numbers, make sure you typed everything, all the negatives, all the positives. Just going to label this one. This was A. This was our variables. And this was B. All right, we're going to switch it up on the back. On the back side, We're not told what type of polynomial it is, so we have to do something tricky. Can you lift your head, Ria? Thank you. Alright, there is a way to figure out a degree, though, if we don't know the degree. Manas, did you already figure it out? You know how to find the degree? You don't know how to find the degree? What? Oh. Wow, okay. Alright. Sometimes I wonder if he's the smartest person in class. Now I've retaken championship. Okay, here's how we find the degree. What we're going to do is we're going to find the differences in the y values. Okay, how much the y's change. So I'm going to start with the first change in the y. So not the x's, we're just looking at the y's. This y goes from an 8 to a 14. That was an increase of how much? 6. Okay. This y goes from a 14 to a 24, which is an increase of 10. This is an increase of 14. This one goes up by, what is it? 56 minus 38? Yes, 18. And then this one goes up by, okay, these numbers right here are what are called the first differences. I'm going to point to that. These are called the first differences. That says fifth differences. First differences. Oh, 22. Thank you. Sorry, that should be 22. Okay. Now, if your first differences happen to all be the same number, this would be a linear function. That happens on linear functions. When you go from y to y to y, that's called the slope. Okay? If your first differences happen to be the same number, that would be a linear function. But ours are not the same number, so what does that tell us? It's not a linear function. Not linear. So guess what we find next then? The second differences. Okay? The second differences are the differences between these differences. Okay? So 6 went to 10, which is an increase of 4. 10 went to 14. That's also plus 4. And 18 went to 22, which was a plus 4. These numbers are called the second differences. Okay. If your second differences match, that tells you whether or not it's a, what do you think? It tells you if it's quadratic, right? And my second differences match, so what do I know? Quadratic. This is quadratic. Now, this process can continue. You can find third differences to tell you if it's cubic. You can find fourth differences to tell you if it's a quartic, a fourth degree. But these second differences match, which means these represent a quadratic. Okay, so now we know it's quadratic, which means we're going to do like we did on the first problem on the front. Our blank quadratic equation is ax squared plus bx plus c equals y. Okay. Now when we write a quadratic, how many missing variables does it have? 2. Nope, not 2. 3. We don't know the a, we don't know the b, we don't know the c. If you have 3 missing variables, how many equations do you need to write? 3. Do we have way more points than we need? Yes, we only need to use 3 of those. Okay? Choose your favorite 3 when you're writing your equations. Plug in x and y. Which 3 of these points do we want to use? 114. 2 more.
578.
Oh, you want to plug in 5? 578. And 1 more? 224. Now it actually doesn't matter which one you plug in first, which one you plug in second, so completely fine that we did them out of order, not a big deal. Plugging in 1 for x and 14 for the y. That would be 1 squared times a, which is 1a, b times 1, which is b, c doesn't have an x, so just write c, equals 14. Next one, we're plugging in 5. 5 squared would be 25, so that's 25a. And then b times 5, 5b, and C doesn't have a variable, and then Y is 78. And then lastly, plugging in 2 for the X, so 2 squared would be 4. 4 times A is 4A. B times 2 would be 2B. C doesn't have an X, so just write it down. Equals 24. All right, let's take a couple of minutes. Let's work with our group and let's get the answers for this one. We want to write it in full standard form quadratic. If you're having trouble remembering how to type it in, that would be a good time to talk to our group. You can also compare answers at the end. What do you think? 2 minutes we could get it done? 3 minutes. 2 minutes? I'm doing 2 minutes. Hey, Ron. Tyranny. Blood time. All right, 5, 4, 3, 2, 1. All right, I ended up with this as my variable matrix, which means the A value of my quadratic is 2, the B value is 4, the C value is 8. So I'm going to make sure I get those put back in my standard form quadratic here. So we'll have Y equals 2x squared plus 4x plus 8 for our final answer. Okay, questions on this one? All right, same thing on the next one. We're not told the degree, so we are going to have to find out the degree first. And to find out the degree, we're going to look at those differences. We're going to try first difference, then if that doesn't work, we'll try second difference. If that doesn't work, we'll try third difference, and if that doesn't work, we're going to try fourth difference. All right, looking at those changes. Again, you're looking at the changes in the Y values. So 6 went to 15. That is definitely an increase, but an increase of how much? 9? Okay. And then 15 went to 22, increase of 7. Okay. 22 went to 21. Oh, that's our first decrease. So that would be minus how much? 1. And then 21 went down to 6, which would be a decrease or a minus of 15. And 6 went down to negative 29, which is a big decrease of how much? 35. So again, these are called the first differences. These numbers tell you whether or not your function is linear. A linear function will always have this. They'll be matching if that's its slope. But ours doesn't match, so what do we know? It's not linear. So then we're going to look for our second differences, the differences in these differences. Okay, so 9 goes to 7, which is a decrease of 2. 7 goes to -1, which is a decrease of, not a decrease of 6, a decrease of 8. Yeah, 7 went to -1, that's down 8. And then -1 went to -15, that's a decrease of 14, good. And then -15 went to -35, which is a decrease of 20. Okay. So these differences are called the second differences. And again, just like the last one, these tell you whether or not your function is quadratic. If these are the same, it's quadratic. So what do we know about ours? Not a quadratic. Okay, moving on then, we're going to find the third differences, the differences in these differences. Yep, that's down 6. This would be down, -8 went to -14, -6. And then -14 went to -20, -6. Our third differences are the same. What type of function is it then? It's cubic. Okay. I will give you a hint. I will never give you anything higher than a 4th degree on a test. So if you get to the 4th degree and none of your numbers match, guess what? You did it wrong. You found some sort of number that was wrong. Go back, try again. I'll never give you anything higher than a 4th degree. Alright, now that we know it's cubic, let's think about that blank function. What does it start with? It doesn't start with an ax squared. It starts with ax cubed plus bx squared plus cx plus d equals y. How many equations are we going to need to write? 4, right? Because there's 1, 2, 3, 4 missing variables, your a, b, c, and d. So if we need 4 equations, we need to use 4 of the points, which is more than we are given. Okay. What 4 would we like to use? 1, 6. Just the first 4 would be good. Yeah, first 4. 2, 15. Actually, 5, 6 doesn't look too bad. 3, 22. 4, 21. 4 points to plug in to create 4 equations. Let's see, plugging in 1. That's 1 to the 3rd power times a, so 1a, also known as a. 1 squared times b would just be 1b. C times 1, c. D doesn't have x, so bring it down, equals 6. Okay, plugging in 2 for the x, 2 to the 3rd power. 2 to the 3rd power is 8, so that's 8a plus 2 squared times b, 4b. C times 2, 2c, and d equals 15. 322. Let's see. 3 to the 3rd power is 27a. Good. That would be 9b. C times 3 would be 3c plus d equals 22. And then lastly, plugging in 4. What's 4 to the 3rd power? 64, so that's 64a. 4 squared would be 16. 16 times b. C times 4 plus d equals 21. Again, just like the last one, I'm going to have you guys work this one on your own, and then we'll turn and tell our group what answer we got. Make sure everybody got the same answers. I'm going to do a 3-minute timer on this one just in case It does have one more equation, so that's one more to type in. I guess it would be nice for me to have the answer to this one because I don't have an answer to check with y'all's answer. I'm gonna speed run it. All right, we're going to check our answer together in 15 seconds. Make sure you're ready. Yes. Let's see. All right, coming back together to check. Using my calculator to find the variable matrix. I got these 4 numbers. Did y'all get these 4 numbers? Make sure you don't just write this. Make sure you actually go back and write the cubic function that has these plugged back in place. Okay, so we know that the a on the x cubed is 1, so that's negative x cubed. Our b is 5, so 5x squared. Our c is 1, so that's plus 1x, or just x. And then d would be plus 1, and that is our function. Good? All right.